Greetings everyone, this is Mr. Mull, and in this video we're going to spend some time looking at some centripetal acceleration example problems in order to help you do some problems from the book. And so what we're going to do first off is I would at the top of my paper just put those equations dealing with circular motion. So the big three are the tangential speed is 2 pi r over t, centripetal acceleration is equal to vt squared over r, and the centripetal force is mvt squared over r. And so these are going to be our three big equations here. We're going to be able to use these to solve some problems. So the first problem that we're going to do, it has a test car, is moving at a constant speed around a circular track, so we know we're talking about circular motion. If the car is 48.2 meters from the track's center, okay, so there's some information about the radius, and has a centripetal acceleration of 8.05 meters per second squared, and it asks what is the tangential speed of the car. So I'm going to start by writing some things that the problem gives me as knowns. So I know that the radius of this thing is 48.2 meters. It also said that the centripetal acceleration is 8.05 meters per second squared, and the first part of the problem is asking for what is the tangential speed. So I look at my big three equations, which one deals with these three variables, and there it is, number 2. So I'm going to take my original equation, centripetal acceleration is equal to vt squared over r. I want to get vt by itself, so I'm going to multiply both sides by r. Vt squared is equal to acr, and then I'm going to take the square root of both sides, and we're going to get the Vt is equal to the square root of AC times the radius. And so now I can plug in. Vt is equal to the square root of, the acceleration was 8.05, and then the radius was 48.2 meters. And when I plug all those in, I'm going to get a tangential velocity of 19.7 meters per second. The second part of the question says, how much time does it take him to go around the track once? Okay, that whole going around the track once, that's one revolution. And the time to go around once, we call that the period. So what we're really looking for in part 2 is the period of the car. And so now that I know that the tangential velocity was 19.7 meters per second, now I'm going to go back and look at my first equation dealing with period. And I know that the tangential speed was equal to Vt is 2 pi r over t. I want to solve for t. So I notice that it's in the denominator. We got to get it up to the numerator. My favorite way to do this is to cross multiply and isolate t by itself. So Vt times t is equal to 2 pi r, and then divide both sides by Vt. We get that the period is equal to 2 pi r over Vt. So in order to solve for t, we're going to go ahead and plug in the known values for those variables, 48.2 meters for the radius. The tangential speed was 19.7 meters per second. Meters on top, meters on bottom, seconds get flipped to the top. Our unit is going to be in seconds, and we're going to get 15.4 seconds is going to be the period, or t. And so now we know how long it takes to go around once. The last part of this question says, what is the object that supplies the net unbalanced force required to move an object in a circle? Okay, we have a name for that. It's called the centripetal force. So it doesn't actually ask us how much force is there, even though we could totally find it if we needed to. Just ask us to describe that force. So it's a car moving in a track. It's a circular track. There needs to be something. And so if it were on ice, it would be going in straight lines, but it's not on ice. And so we can go ahead and say that the ground is supplying a frictional force. And then we're going to describe this interaction. The tires are pushing the ground outwards, and the ground pushes the tires inward. And that would be our centripetal force. And if I wanted to calculate it right now, I could go to this equation, now that I know all those other three things, plug them in, and we could find the centripetal force, Fc, as well. Alright, we're going to go ahead and do one more example. The next example has a plane flying in a circle, and it says it takes 20.9 seconds to go in a circular path, and it gives me a diameter of the circle is 377 meters across. It says the centripetal force needed to maintain the plane's circular motion is 1.89 times 10 to the 4th newtons. It asked me to find the tangential speed of the plane and then to solve for the plane's mass based upon the information they've given me. In the last one, we're going to talk about the force that's involved. So I'm going to go ahead and start by taking and reading through the problem. It gives me a time to go around once, and that's going to be the period. It was 20.9 seconds. The next piece of information it gives me is the diameter, and I'm going to go ahead and divide that by 2 so that I can figure out what the radius is, because all my equations deal with the radius. It also gives me the centripetal force acting. It was 1.89 times 10 to the 4th newtons, and it's asking to solve for the tangential speed of the plane. Alright, so there we go. So I'm going to look up at my top equation, and to find tangential speed I need 2 pi r over t, and thankfully I know the radius and the period, so this is going to be no problem. Vt is equal to 2 pi r over t. Vt is equal to 2 times pi times the radius, 188.5 meters, and then the period was 20.9 seconds. And then when I punch those all in my calculator, we're going to find that this plane was going 56.6 meters per second. That's how fast we were going. Now that I know the speed, it asked me to solve for the plane's mass, m equals question mark. So I look at my 3 equations, and I want to find one that involves the mass. So there's only one, and that's going to be the centripetal force equation here, number 3. So I'm going to go ahead and write that down here. This is part 2. So the centripetal force is equal to mvt squared over r, and I want to get m by itself. So I'm going to multiply both sides by r. So I get FCR is equal to mvt squared. And then I'm going to divide both sides by vt squared to get m by itself. Okay, and so m is going to be equal to Fc times r divided by vt squared. And so I can now solve for my mass. I'm going to plug in the force, centripetal force, 1.89 times 10 to the 4th newtons. And then I'm going to plug in the r radius, 188.5 meters. And we're going to divide that by the velocity squared, 56.6 meters per second. And we are going to square the value. And so when I plug that all in my calculator, we're going to get that the value of the mass is going to be equal to, with 3 sig figs, 1,110 kilograms. Okay, very nice. Last part of this says, what is the net unbalanced force required to move the object in the circle? So this is talking about the centripetal force, but remember, it could be any type of force, really. So I'm going to look at this problem, and it has a plane flying in a circle. Well, planes don't just fly in a circle unless there's something causing them to go towards the center. And so if I think of my little plane in the air, okay, what is my little plane doing as it goes around the air, and it has to be pushing on some physical object, so it's going to be a drag force, or force of air, and as the plane pushes out on the air, then the air is going to be able to push in on the plane. So we're going to go ahead and say this is the air, and this is a drag force, so air, drag, and we're going to say that the wings push out on the air, and the air pushes in on the wings. Okay. All right, this is going to be some example problems to help you finish up some problems out of the book. Please read the directions carefully, and I hope that this was helpful.